Mystery lunar domes and missing moon trees. You're listening to Are We There Yet? The radio show exploring space exploration. Hi, I'm Marian Summerall, filling in for Brennan Byrne. University of Central Florida scientists are sending instruments to study unique domes on the lunar surface. These domes formed from a sticky magma, but on Earth, domes like this need water and plate tectonics to form. So how are these domes on the moon? We'll speak with UCF's Carrie Donaldson-Hanna about her efforts to study this lunar dome mystery. Then during the Apollo missions, tree seeds were taken on trips to the moon and returned to Earth to see if the trees would grow differently, but some of the trees have been misplaced or died. NASA's Dave Williams hopes to find and preserve the trees and their history before they are lost with time. That's ahead on Are We There Yet? As part of NASA's Commercial Lunar Payload Services, or CLPS, researchers are sending science instruments to the moon. One of those instruments will study a mysterious part of the moon, the Gruth-Thyssen domes. The domes form from silicic lava, something we only see on Earth from water and plate tectonics, making scientists wonder how these domes were formed on the moon. The Lunar Vice mission will do just that. With 5 instruments, the mission will study the domes over 10 Earth days, collecting data and returning it to Earth. I took a trip over to UCF to speak with Associate Professor Carrie Donaldson-Hanna, the principal investigator of Lunar Vice, to learn more. Here's part of that conversation now. Well, Carrie, not everyone is doing the work that you are doing with the moon. Is there something that started it all? Were you always fascinated with the moon?
As a kid, I was definitely interested in space and just the idea of going into space and studying things out in space. But of course, as a kid, you never really know what that means. And it wasn't until I went to do my undergraduate degree at Florida Tech that I had a research experience over the summer where I was doing telescopic observations of Mercury, and I was looking at data of Mercury. That was kind of that first little spark of, oh, this is really cool. Like, we can use a telescope and we can study planetary bodies in our solar system. And, you know, the moon has always intrigued me because it's so close. Like, we can see it with our own eyes, you know, when we look up at the sky, whether it's in the day or the night. And it just seems maybe more tangible, I think.
So you've always had this fascination with the moon. Let's talk about your work along with a fellow UCF professor, Addie Dove, right?
The mission, the Lunar Vulcan Imaging and Spectroscopy Explorer, what we call Lunar Vice, really started when I arrived at UCF, and Addie Dove and I were thinking and talking like, how can we collaborate on a project? You know, I like to study rocks and the dirt that comes from those rocks, and I really like to do that to understand the composition and what that means for how the moon formed and then evolved over time. And then Addie likes studying the dust, but in a completely different way, because she likes to see how dust is lofted, how spacecraft interacts with it. But we were like, but we use kind of similar data sets. And so, you know, what a combo would that be if we combined our forces together? And so we were approached from Ball Aerospace to work with them on a project leading a small payload to go to the moon. And so then, knowing what NASA was looking for based on the landing sites that they had selected for the moon, we thought, okay, what science questions can we address there? What instruments would we need to address those science questions? And then what people do we need to add into the team? And we feel very lucky that Arizona State University wanted to work with us to provide an instrument along with the Ball Aerospace instruments. And then we got a great team of scientists that were willing to join us on this endeavor.
What was that like presenting this project to NASA? What was the process like?
For all of these flight projects, NASA requires you to write a proposal. And so we worked over a 6-month time frame, but we spent about 6 months conceptualizing what we would do, what instruments we would need, and then we started writing that into a 25-page proposal. And then we found out in June that we were selected. So we were patiently waiting. we had hope, that we would win. And we certainly believed in our concept and the suite of instruments, but we were still pretty shocked that we got selected.
Could you do this without NASA or the commercial lunar payload services?
There's kind of like two parts to that question. So our payload got selected through the PRISM program. And so that was a NASA program to select a suite of instruments to do a science investigation on the surface. And so through that, NASA picked our payload, and they are going to then pick a CLIPS vendor that's going to build our lander and rover. And so essentially NASA is guaranteeing that CLIPS provider a payload and money to help get that business going, right? So for us, we could not do this without CLIPS, because CLIPS is essentially going to be our ride to the moon. So we need them to build us a lander and a rover. So we're highly dependent on that. And so in the upcoming months, NASA will set out a proposal to the CLIPS providers and give them all of the requirements that we need to be successful at the surface. And then all the CLIPS providers that are interested will respond and write a proposal saying how they would make us successful at the surface by building a lander and a rover. And then NASA will select one.
Now, I really want to know some of the instruments that are being sent to the moon. Where are they going, and what are you sending?
Our suite of instruments are going to go to a volcanic feature called the Gruithuisen domes. And so these are small volcanic features that when you look up at the night sky, if you had a telescope or binoculars, you could actually train your eyes and see them. So they are on the lunar near side, but they are very small features. And because of the way they form, they have very flat tops. So that means the magmas come up from the interior and slowly cooled and created this very flat plateau that we're going to land on. So we're actually going to land on the top of this volcano. We'll land there, and then our rover will disembark and we'll drive the rover over the top of this volcanic feature. Now, on the lander, we're going to have two cameras. We're going to have a camera that's looking at the volcano as we're landing, and that will give us a few things. So one, it'll allow us to get a really great image of where we're going to land and where we're going to rove. And then it'll also allow some of the work that Addie is really leading, which is looking at how the lander plumes are interacting and disturbing the surface, and how much dust is lofted, and how much it scours the surface, and how much it disturbs the landing area. We'll also have a camera on the lander that is looking out around our landing site, and that will be used to characterize the geology of the landing site, help us pick where we're going to drive the rover. We'll also be using the camera on the lander to watch the rover. And so as the rover is driving and disturbing the surface with its wheels, we'll have the capability of taking images as well as videos of seeing how the wheels really interact with a regolith. And again, that really will help us and help Addie, who's leading that part, to really understand how the regolith behaves and what does that tell us about what tools we might need to develop in the future to be able to better interact with that material. On the rover, we have two main instruments. We have a gamma ray and neutron spectrometer, or GRNS, that ASU is building for us, which is Arizona State University. And as we're driving around, it's essentially measuring the elemental composition of the surface. And so it'll tell us how much silica and iron and magnesium and important things like thorium and uranium and potassium as we're moving about. And then the instrument that I'm more kind of like or overseeing is the VIMS instrument, which includes actually two cameras. So we have two multispectral cameras that are pointed in the same direction and that will rotate together. One looks at wavelengths that our eyes are sensitive to. So as sunlight hits the surface, it reflects back. And so we'll be measuring that signal. And then we'll also, with the second camera, be looking at the heat that's coming off of the surface. So it'll be a thermal camera. And so with those two combined, we'll be able to look at the minerals that are making up the dome and the types of rocks that are making up the dome.
Could this lead to some of the origin questions of how our universe formed?
Yeah, well, we see the Grooteisen domes are very unique in that from our spacecraft data, they seem to be very enriched in silica. But they're not the only features that appear to be enriched in silica. There's actually about 10 of these locations across the lunar surface. But we just don't understand how we could get magmas like that on the moon. Because when we look on Earth for where we see really silica-rich magmas, we see them in places like Mount St. Helens. And if you think about what's happening at the volcano in Mount St. Helens, you have two plates. This is a plate boundary between plate tectonics. One is actually going under the other. And as it's going under, it pulls some of the ocean water. So you have these interactions between a subducting plate with plate tectonics with the ocean water that allows the magma to evolve into being very silica rich. If you think about what I just told you, and then you think about the moon, do you see vast oceans on the moon? The answer is no. We also don't see evidence for plate tectonics on the moon. Then how could we be getting similar types of rocks on the moon, in comparison to what we see on Earth when we don't have the same tectonic or volcanic settings? And so that's where that science question is really being driven from, is like, whoa, these are really cool rocks, but we don't know how they formed.
UCF is known for its space and planetary contributions, so you really are contributing to that legacy, right?
Usually I try to start off each class with like kind of an in the news topic, right? Just because the students are very aware here at UCF of things going on in space and in planetary science because, well, we're the Space University and we're so close to Kennedy Space Center. And so I think it's really cool to try to tie in what I'm going to be lecturing for the day into what's going on in the news, right? And so some of that has been involving talking about the lunar vice work and some of the other projects I'm working on. And yeah, I mean, I think the students, at least the ones that, I interact with, they certainly seem very excited, to know that these types of projects are happening here at UCF.
And lastly, how do you feel? You've passed some critical testing, you're working towards your goal. How excited are you? Are you nervous? I mean, this is a really big deal.
I almost get a little emotional thinking about like what it's going to be like to get those first images down. Even just seeing how things have went with the Intuitive Machines 1 and it tipping over, but they still got images, right? And like just sitting on the edge of your seat waiting for those first images to come down and thinking, oh man, in a few years that's going to be us. And yeah, it's kind of surreal in a lot of ways to think that we're going to land in an all new location on the moon. So completely different than where any of the Apollo landings happen. It's completely different than where from the South Pole. So we're going to be seeing completely different terrain. But certainly as a team, we all really see this as, certainly we're doing this for our team and ourselves, but we also see the responsibility of doing it for the community and the United States and the world, right? Like everyone's going to be able to use our data, not just us. Everyone's going to be able to see those images, not just us. And so it makes you feel a little stressed, but it also makes it exciting too.
That was Carrie Donaldson-Hanna, the principal investigator of Lunar Vice. Still to come, tracking down the lost moon trees. That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Marion Summerall, filling in for Brendan Byrne. Astronaut Stuart Roosa carried a variety of tree seeds on 1971's Apollo 14 mission. It included sycamore, sweet gums, Douglas firs, loblolly pines, and redwood seeds. While the trees did come back to Earth and get planted, some of them did not survive germination. An estimated 120 trees were planted around the United States, but an exact record of the trees was never kept, leaving the status of many of these trees unknown. Our intern Sophie Diaz tracked down NASA space science data researcher Dave Williams to speak about his efforts to save the trees left and collect records of where these missing trees may be. Here's part of that conversation now.
Well, Dave, welcome to the show. To start us off, what are moon trees?
Okay, so in 1971 on Apollo 14, the command module pilot Stuart Roosa, before he became an astronaut, worked for the Forest Service, and as part of his sort of tribute, I guess, to the Forest Service, he wanted to do something, and he got together with some of the people there at the Forest Service, and they gave him about 500 tree seeds, tiny little seeds, that he took with him in his personal kit. So each astronaut got a personal kit. He brought these seeds with him. He orbited the moon in the command module. He was the one astronaut of the three who did not go down to the surface, but he orbited the moon, brought the tree seeds back to the Earth, and basically handed them over to the Forest Service, and the Forest Service germinated them. And then for the bicentennial in 1976, about 5 years later, they had a bunch of little saplings. They sent these all over the country, and they were planted just all over the country as part of bicentennial ceremonies for the most part. And they're still growing. No, those are the moon trees.
Wow. How did you stumble on the story of Apollo 14 and the moon trees?
It's very funny. Part of my job involves working with a lot of the old Apollo data. And so I had web pages basically with information about Apollo and the data with my name on them. And so I got an email in 1996 from Joan Goebel, who was a third grade teacher in Kennelton, Indiana, who said they were doing a project on local historic trees. And one of the Girl Scouts in her class said at the Girl Scout camp, there was a tree and it had a sign on it. It said it was a moon tree. And she knew it had something to do with Apollo, but really didn't know much more about that. And so she saw my name and asked, did I know anything about these moon trees? And I'd never heard of them. But I'm at Goddard Space Flight Center. There's a lot of people there who did work on Apollo, especially back in 1996. So I sort of asked around, what are these moon trees? Well, no one had ever heard of them. So everyone I talked to, they just gave me these funny looks like, no, moon trees. What are you talking about? I got online. Of course, this is 1996, so we didn't have the search engines, and the amount of material online wasn't quite what it is today. But I found a little bit about the moon trees, and then I also contacted the NASA History Office, and they sent me some newspaper clippings. They had a little file, and it had like 3 or 4 newspaper clippings. So I kind of went through all this, and I kind of put it together. And I answered Joan, and I said, basically, here's what they are with my rudimentary knowledge sort of the moon trees at that point. I thought, this is such a great story. And no one knows about it. And I thought, well, I've got pages with Apollo information already. Let me make up a page. Let's make up a simple page. I will put on the page what I know about the story. Between the clippings and what I found online, I found about 6 trees. I put up a little list of the trees, and I said, if you're reading this and you know any about a moon tree, please let me know. And I started getting emails.
So how large was that initial public response when you put out that call for the moon trees?
It was a very slow climb. It was just sort of, I think people sort of stumbled across the page here and there. And, every once in a while, someone would recognize that they'd seen a plaque, at the state capitol building or like I said, in a park or a little museum, and something about a moon tree. And they'd write to me. They'd take pictures and send them to me and find background and stuff. So it sort of like had all these little people out there helping me find all these moon trees, which was pretty cool. So it would trickle in. A few times, some people from the Forest Service came across the page, or someone told them about it, and then they got in touch with me, and so I actually managed to talk to some of the people who actually were involved with the moon tree program. So I got a lot more information from them. Stuart Roosa had passed away in 1994, but I did hear from his family, who also, came across the webpage and started telling me, other things about it. And so every once in a while, there's a magazine article about it. Someone stumbles across it and they do a magazine article. And then sometimes I'll get a big sort of a little bump, I guess, in my in my emails and the information I get. Because more people actually see that than just kind of stumble across it on the web.
So you said that the public plays a big part in this. Have you yourself gone out to check on any of the trees or even meet a couple of them?
Yeah, I have. I haven't seen that many, but we have one at Goddard Space Flight Center. So it's at the visitor center there. So I see that one all the time. I've seen at least one of the redwoods in California. I've seen in San Luis Obispo. I did get invited by Joan Goebel, the third grade teacher, out to Indiana. They had a little dedication for their moon tree, and I got invited out there. So that was fun. I went to that, and I met a bunch of the people from the Forest Service there, and they took me around the state. And so I saw a lot of the trees in Indiana, of all places. So I've gotten to visit a fair number of them. I have this great idea. I'm always thinking, I'll see if I can get funding from NASA to just go around the country and visit all the moon tree sites. I don't think that's going to happen, but it might be a good retirement project.
What makes you think that there was no exact record of the trees before?
At first, I really didn't understand this. I think I understand it now after all this time of understanding how the whole thing worked. Basically, the problem was that it was really a public relations thing. It wasn't a science experiment. They tried to see if there were any changes, but no one expected there to be any changes, and there weren't. But it was mostly public relations. So for one thing, it wasn't kind of a systematic thing like a science experiment would be. Two, there were really three kind of groups involved in this. So one was NASA, obviously, took the seeds and brought them back. And then the Forest Service, who ended up, getting the seeds and germinating them, and then all the different state governments. So the seeds were sent from the Forest Service out to the states. For example, they may have sent 3 trees to Montana and 3 trees to Idaho. And basically what happened once it got to the states is it depended on the state if they really kept track of what happened to, where they went or who they gave them to. I found information, or other people have found. Well, I always say I found this stuff. It's always other people, who are telling me this stuff. So there's all these other people doing all the work. We found that some of the state archives had some information about the trees, and you could find out where, maybe they were planted and things like that. But for the most part, at that point, it was very haphazard. And so there's no systematic list of the trees. There's no systematic records, and you have to kind of really find them like one at a time, kind of.
Got it. And so with the full moon trees, I know a few of them went unlabeled. What kept municipalities or the planters from labeling them?
Yeah. So what happened was the trees were very small when they were sent out. They were just little seedlings. They were 3 or 4 feet tall. And a lot of places, people were really worried that after they planted them, that someone would come along and steal them. Because it would be pretty easy to do. You could pretty much just, pull them out of the ground practically, especially right if they were planted. So people were worried that someone would come along, oh, I really want a moon tree, and they'd steal them or vandalize them. So they didn't mark them. I think. I mean, a lot of times they would come back and mark the trees. But other times, I have a feeling that, time went on, people move along. 2-3 years later, it's kind of been forgotten. And, oh, yeah, we were going to put a marker there. Yeah, we'll get to it. And it doesn't happen. And the tree goes unmarked. Another thing that they did was, because the trees were so young, in some places they were worried they wouldn't even grow if they were left outdoors. They wanted to keep them in a greenhouse for another year or two before they wanted to plant them. So they plant stand-in trees. And they didn't always mark those, obviously, but by the time they got around to planting the real tree, they just didn't put in a marker. So I think there's may well be a fair number of trees out there that are completely unmarked and basically forgotten. They're moon trees, but you will never be able to know that.
So there's no difference between these moon trees and their earthbound counterparts?
No, nothing. They couldn't find anything. Now, the one thing I thought of is the seeds were collected. They did keep records of where the seeds were collected from. So, for example, all the redwood seeds were collected from a certain area in California. And then all the Douglas fir seeds and the sycamore seeds were collected from 1 or 2 areas. So I always thought that if you had a tree and you were pretty sure it was a moon tree, you could actually take a sample of the tree and check the DNA and see if it matched. For example, they collected some of the sycamores, I think in North Carolina, let's say, that if it matched DNA from trees in North Carolina and this tree was, in Ohio, pretty good bet that that's a moon tree. It's not like the seeds, blew all the way to Ohio and germinated there. So I always wondered if that was possible. But other than that, though, it would be really, really, well, I wouldn't say hard. It's probably impossible to tell if a tree was a moon tree or not.
What's important to you about keeping track of these trees?
It really just struck me as a very cool story. Just thought it was the idea of having trees being a sort of a representative of the Apollo program, of all things. I mean, what's sort of more kind of earthbound and sort of primitive than a tree, and what's more spacey and futuristic than going to the moon? The contrast, I think, is kind of neat. And just the idea that Stuart Roosa, he really wanted to sort of pay tribute to his time in the Forest Service, and just basically he was always a real nature lover, apparently, and he really wanted to pay a tribute to that, and so that he actually did this. He actually brought these seeds with him to the moon, brought them back, and now they're all over the country, and it's fun. I mean, I have to admit, it's always fun. I hear from people all over the country, and I get all these stories and hear about the trees. So I'm definitely enjoying it myself.
Are you hoping to see better record keeping with the trees that just went around on the Artemis mission?
Yeah, I'm sure there will be. I'm not directly involved with it. I mean, this keeps me busy enough because this is really just a sidelight. I mean, this is it's not my main job. So I don't always have an awful lot of time to work on it. It keeps me plenty busy taking care of these. So I'm happy not to have to be trying to keep track of the Artemis trees as well. But I'm pretty sure, yes, I'm very confident that they're keeping very careful track of where the seeds are going, and I hope, sort of following them along as they grow and how they're doing as well. And I think they are. Well,
Dave, thank you so much for joining us.
Yeah, thank you, Sophie. It's been great talking to you.
That was NASA space science data researcher Dave Williams. That's going to do it for this week's show. If you're not already, be sure to subscribe to this show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Stay connected with the show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. Are we there yet? AWTY, get it? And if you've got an idea for a future episode of this show, or you want to join us as a guest, reach out to us. We're at awty@cfpublic.org. We've got more space coverage online. Visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our host is Brennan Byrne. Our producer is me, Marion Summerall. Our intern is Sophie Diaz. Editorial guidance from Latoya Dennis. Support for Are We There Yet comes from our listeners. I'm Marion Summerall. Brennan's back next week. Thanks for listening.